Hi Year 3, Happy New Year and welcome to this week's maths video. Now, we're really disappointed that you can't be with us here in school, and I'd love to have you here in the classroom with us doing the lesson together, but until we're able to see each other again, I know you'll do a brilliant job with your home learning, and I'm sure it won't be long until you're back in the classroom again and we can do some more work together. Now, even though I'm filming this on a Wednesday, so you've only had one day of home learning so far, but before I start, I just wanted to share, even on the first day, some of the amazing work that's been sent in to us at the Year 3 account. We had some amazing 2 times, 4 times and 8 times table work from Madison in 3P, the same from Esme Grace in 3B as well, and we can see that Millie in 3C has been working really hard as well. So just because you're at home doesn't mean you can't earn dojo points for those children's fantastic hard work. I can go on to Class Dojo. I'm going to add on some dojo points for aspiration. There's one for, where's Millie? She's down here. There's one for Millie. And then in 3B, there's one for Esme Grace. And then finally, in 3P, an aspiration point for Madison as well. And as well as all the fantastic work that's been sent in so far, we've also been keeping an eye on to see who's been working hard on the online learning for maths as well, like TT Rockstars, Numbots, Math Shed. Not just yesterday, but a few of you even went on over the Christmas holidays and had a little practice as well, which was great to see. So let's have a look at who's been doing a brilliant job on those 3 things this is over the last 7 days. So on Math Shed, you can see here in 3B, we had Lily W, Zoe R and Alfie M as the top 3, well done. Ren, Harry and Nathan in 3C, Leo, Isabella and Casey in 3H, and Grace, Gabrielle and Amelia in 3P. So well done for all of you guys. You'll be getting some dojo points put on afterwards as well. And overall in Year 3, the first place went to Grace in 3P. Fantastic job, Grace, well done. Gabrielle was second overall in Year 3. Well done, Gabrielle. And third was Leo by collecting loads and loads of points on Math Shed. So well done to you 3. And on TT Rockstars, we had a little look at who earned the most coins, which was Madison, Rahman and Oscar. Fantastic job, you guys as well. These 3 children, Lily, Rose, Zach and Rory from 3P have all been getting faster during the last 7 days. And also, Lily, Rose, top again, Georgia and Ethan from 3H have been improving their accuracy as well. So you guys will also be earning yourselves some dojo points, well done. And finally, we know that we've looked in school. We haven't done it quite as much, but there is Numbots, which, as well as the times tables, is where you can practice your addition, subtraction, your mental arithmetic skills. And we've got a top 10 here of children who've logged on over the last 7 days. And the most coins earned on Numbots was from Ethan D in 3H. Well done, Ethan. And then you can see there Oscar Day, well, DA, because I know there are 2 Oscar Ds in 3H. Abigail in 3B, Rahman in 3H again, Matthew in 3P, Tamara in 3C, Jacob and Ruben in 3P, Lily in 3B, and finally Charlie R in 3H. So, fantastic job. If you haven't had a chance to go on yet, that's okay. I know it's been a very mad, busy start to the week for everyone, but hopefully over the next week or so, you'll try and challenge yourself by logging on to TT Rockstars, Math Shed or Numbots to practice some of your mental arithmetic skills. Now, for today's maths lesson, as usual, we're going to do a bit of a starter to get our brains in gear before we start the learning. And today we're going to get up and active and around our house by going on a bit of a number hunt. So in Year 3, we look at numbers between 0 and 1,000. And I wonder whether in your house you can spot any of those numbers. You might spot some pretty big, obvious ones. Or maybe you might even find some sneaky ones hidden away. And when you've jotted down on maybe a scrap piece of paper all the numbers that you can spot in your house, maybe you could challenge yourself by asking some questions about them. So, what's the greatest number you found? What was the smallest number, the lowest number with the least value? And here's a 3 chili challenge for you. What's the difference between the numbers you found? Which are odd, which are even? And how many digits they have? If you're searching for numbers between 0 and 1,000, you might find a 1-digit number, a 2-digit number, maybe a 3-digit number. But hopefully you have fun looking around your house, don't make a mess. And then when you get back, see what you can find out about those numbers. Today's lesson, our learning objective is sounds quite complicated. It's a bit of a long hello, but it's not, don't worry, because it's to use known multiplication facts to solve related calculations. And all that means, known multiplication facts are the times tables facts that we already know, or we could work out with things like arrays or drawings, which I know you know loads of. And the related calculations are just other number facts that actually we don't always need calculators to work out the answers to huge multiplication problems. We can sometimes use the multiplication problems we already know to help us. Now, some of the vocabulary we're going to see when we talk about multiplication are, obviously we know this is the multiplication sign that you can show us as well, and there are those related facts and known facts, things we already know or could work out quite easily and quickly. Whenever we deal with multiplication, there's lots of vocabulary that we might come across, like multiply, times, groups of, lots of, repeated addition, the product, that's always the answer to a multiplication problem, is called the product. The product of 3 and 12, 3 and 4 is 12. Multiplied by, and finally array, which we're going to have a little look at in a bit as well, something you've done in school. So, we're going to start by having a little look at some of these counters. Now, for this lesson, you'll need just a scrap piece of paper or a book to work in. And also, you might have still, hopefully, when we sent out some resources before Christmas, I think it was even before Christmas, earlier on in the year, you had a few of these sheets where you could cut out your own counters if you wanted to help you. And if you don't have those, you might just find something in your house that you could use as counters. You might have some cards, you might have some coins, just something that can help you lay them out to make some arrays. Or if not, you could draw them. Now, I wonder if you can work out what number sentence is that array showing? That's right. This number sentence, this array, well, it could be showing two number sentences. It could be showing 2. Whoops, I don't know why that didn't work, sorry. It could be showing 4 groups of 2, or it could also be showing 2 groups of 4, 2 times 4. And the answers to both, well, we could count in 2s, 2, 4, 6, 8, or we could count in 4s, 4, 8. And the answer to both of those calculations is 8. Now I wonder whether with your counters, maybe now you could make an array for a multiplication fact. I wonder if you could make an array for 3 times 4 with your counters and see what the answer is. Will you count in 3s? Will you count in 4s? Are there 2 different number sentences you could make from an array? And throughout, if you need to pause it, just pause, because I'll go on and I'll show you as well. So pause at any time to have a go at some of the activities. Now hopefully, for 3 times 4, your array looks something like this. You might, for 3 times 4, 3 groups of 4. There's one group of 4. Oh, pen's been a bit naughty today. Let's try again. There's one group of 4, 2 groups of 4, 3 lines of 4. And I could count in 4s to find the answer. 4, 8, 12. If not, it could be 3, 4 times. 3, 6, 9, 12. The answer's the same either way because multiplication is reversible. Now, let's start to think about some of those related facts from what we know. Now, this array is the same. Well, it looks the same. But what happens if each counter is worth 10? What's the same and what's different about it? Now, let's see how we can use the facts we know to work out some related facts when those counters are worth 10. Now, for example, this one, let's have a go together with an hour term. We know 3 times 3 is, well done if you said 9. I could count in my 3s, I might know it mentally, but if not, there's 1 line of 3, 2 lines of 3, and there's 9. Now, all of a sudden, this one, well, I've still got my 3 lines, but those lines aren't 1s anymore, are they? They've swapped for 10s. And actually, what's each line showing? Let's see. This one is 10, 20, 30, 10, 20, 30, 10, 20, 30. So the counters have got 10 times bigger. And now, instead of saying 3 lines of 3, I've now got 3 lines of 10, 20, 30. 3 times 30. Now, I could try and count in 30s. We haven't really done that before, that's a bit tricky. Or I could count in 3s 30 times. No, that would take forever. Or could this array help us? Could this known fact help us solve this one? If 3 times 3 is 9, well, 3 times 30 is, do any of you know? Well done if you realise that it might be 90. And let me show you, I'll do my turn now and show you how you might have worked that out. So, if we have a known fact, but then we have a related fact where if one of the numbers in the calculation is 10 times bigger, like in the last one, the 3 became 10 times, became 30, well, the answer will be 10 times bigger as well. So, for example, this is my known fact, 3 times 5. Now, I've practiced my 3 times and my 5 times table, so I know 3 times 5 is 15. And if I need to check, I could count in 3s or 5s. 5, 10, 15. And throughout today, if when it comes to doing some of these mentally, you might do them mentally. Again, any time during the lesson, if you need to use your counters to make arrays and find the answers, that's absolutely fine. So my known fact for 3 times 5 is 15. Now again, for this one, this related fact, where it's 10 times bigger because each counter is now worth 10, well, it's now 3 lots of, not 3 lots of 5, but 3 lots of 50, that's right. Now, the answer will be 10 times bigger. If I know 3 times 5 is 15, then 3 times 50, well, that will be 10 times bigger than 15. Well, what is 10 times bigger than 15? Well, it is 15 times 10. Now, we know a few tricks for multiplying by 10, and we know that if it becomes 10 times bigger, then instead of 110, we'll now have 100, 5 tens, so 15 tens now, and then I have to put a 0 in the units column, the ones column as well. So 3 times, or 10 times bigger than 15 is 150. Can you spot the pattern? Now, it's your turn to have a little go at those today, and again, it says you could use the counters if you need to work out the known facts, or perhaps you could solve them mentally. So, to have a go at the 1 chili challenge today, see if you can work out these known facts. I know 2 times 3 equals, and complete it, and then what else do you know from that? Can you make your answer 10 times bigger to work out the related fact, like 2 times 30? And the 2 chili challenge is, if you feel confident with having a go at those, well, can you think of your own related multiplication facts? What other multiplication number sentences do you know you could actually then make one of the numbers in the calculation 10 times bigger and work out the answer without having to use a calculator, because you can use your known facts to help you? And there is a 3 chili challenge, which I'll come on to in a minute, but perhaps you want to pause the video now and have a little go at the 1 chili and the 2 chili maybe challenge, and then press play again when you're ready to have a look at the 3 chili challenge if you're up for it today. Okay? Good luck. Right, okay. You might have waited for the 3 chili challenge. You might have had a go at completing 1 and 2 chili. We'll come back to those answers in a minute. Let's have a look at the 3 chili challenge today, which is quite often a reasoning problem where we're going to have to really read it carefully and see what it's asking us to do. It's all to do with a circus master today. And it says, let's read it together carefully. The circus master needs to sort 240 toffee apples equally into full boxes. The numbers on the boxes show how many apples each one holds. Which boxes could he use? So I'm just going to circle the important information in that problem first to help me. So I know this is important, this number 240, because that's how many toffee apples he's got. Now he needs to sort them equally into the boxes. So, for example, I know if he's got 240, I'm thinking, well, could he use 100 and another 100 makes 200 and then a box of 40? 200, that's not equal, is it? Because 2 boxes have 100 in and 1 has 40 in. So we can only use 1 type of box for each one. And which boxes could he use? So could he share 240 apples equally into groups of 10? Does 10 go into 240 equally? Could he split them into groups of 50, 100? See if you can have a go now, making any jottings you want, and see if you can work out which boxes would work for him. Could, for example, he share 240 equally into boxes of 80? And do you know your 80 times table? Not yet, but there might be some known facts you know. If you know your 8 times table, or if you know your 4 times table, for example, that might help you work out how many times 40 might go into 240. Have a little go. Press pause again now, and then when you press play again, we'll go back and we'll look at some of the answers from today. Good luck. Okay, how did you get on? Let's go back and have a look at some of the answers now, and you can mark your work, and then hopefully you can email it to the Year 3 account because your teachers would love to see it as well. Let's start with this one. So, I know 2 times 3. I know if it's 2 times it's a double. Double 3 is 6. Oh, come on board. There we go. So, this is my related fact. One of the numbers has become 10 times bigger. It's not 2 times 3 anymore, it's 2 times 30. So the answer will be 10 times bigger as well. And I know 6 times 10 is 60. 60 is 10 times bigger than 6. So 2 times 30 equals 60. 5 times 4. Well, I know my 5 and my 4 times table quite well now. We practiced them, and I could count in 5, 10, 15, 20. But now, 5 times 40, one of those numbers, the 4, has become 10 times bigger, so my answer must be 10 times bigger as well. If 5 times 4 equals 20, then 5 times 40, well, it's not 21s anymore, now it's 20 10s, so it must be 200s and 0 10s. And there's a 1 on the end as well, the 0 1s, and 20, 10 times bigger than 20, is 200. 3 times 5 is 15. Remember, if you're ever unsure of these, you could make arrays with your counters. You've got lots of things at home to help you as well in that pack. And so 30 times 5, now this time it's the first number that's been made 10 times bigger. That doesn't matter because multiplication is reversible. So if one of them has become 10 times bigger, in this case the 3 has become 10 times bigger and become 30, well then 30 times 5, the answer must be 10 times bigger than 15. 150. And maybe you had a go at coming up with your own related multiplication facts, and if you did, make sure you email them to the Year 3 account. And finally, this really tricky challenge as well. So it's seeing which of these numbers go equally into 240. Well, if I have boxes of 10, could I get to 240? Well, that one would work because I know 10 times 24 is 240. So that one will work well. I could use the box of 10. Could I do 20? Well, I'm going to use my known facts to help me. I know that 2 goes into 24 12 times. So I know that 20 must go into 240 12 times because it's just 10 times bigger. So 20 would work as well. Let's think about 30. Now I don't know my 30 times table, but I do know 3s, and that's just 10 times bigger. 3 times 8 is 24. So actually 30 times 8 must be 240. So we could use that one as well. I was doing well so far. Could have used the box of 40. Does 40 go equally into 240? Does 4 go equally into 24 to help us? Well, yes, it does. 4 times 6 is 24. So 40 times 6 is 240. Let's see. Would 50 go equally into it? In fact, I haven't worked that out yet. I shouldn't have ticked it, sorry. Well, does 5 go into 24? No, it can't because multiples of 5 end in a 0 or a 5. So actually, I know that 50 can't go into 240 either. Could 60? Does 6 go into 24? Well, yes, it could. I could use my knowledge of inverse operations to do that. 60 times 4 is 240 because I know that 6 times 4 is 24. That works. I already know, I can tell mentally that 100 doesn't work because I can count in hundreds. 100, 200, 300, No, I'm not going to get to 240. And finally, how about this one here, 80? 80, could I split the 240 into 8 blocks? Well, let's see if 8 goes into 24. Let's make it 10 times smaller so you can work it out. 8, 16, 20. Ah, it does. It goes. 8 times 3 is 24. So 8 times 3 is 240. You could use 3 boxes of 80. Well done if you had a go with that. Remember, don't worry if you don't go onto that 3 chili challenge, because that's always there as a real test. Even if you achieved the 1 and the 2 chili challenge today, brilliant job, well done. I hope you enjoyed doing today's lesson. Please email everything that you've done to the year 3 at franchprimary.wrcs.sch.uk email address, because your teachers really love seeing what you've done. And maybe we could give out some dojo points to you, or you could feature in our video next week. Take care, year 3. I hope you're all safe and well, and I look forward to speaking to you again soon. Bye-bye.